All right, well, good morning. It's time to do the second half of this review for balancing equations. So I've already done the first half. This is the second half. We are on the synthesis ones. And at this point, what we're doing is you're given the one side, you got to come up with the other side. So you got HF, and then in parentheses, V, IV, plus N2. So we take that, this little thing right here, don't forget, it being it's in parentheses and it's the Roman numeral, that tells us that this guy would be a +4 when he's charged when he comes across. So synthesis, we're going to take both of them and put them together. Don't bring any numbers across. So don't bring this 2 across. That 2 is there because he's diatomic. Now I do the charges. This one's +4 because of that Roman numeral, and is -3 from the periodic table. So we got to crisscross that. We get HF3N4. Then now you just got to balance this. So I got 1 HF. Don't make the mistake that I've had in the past that people think that 4 means there are 4 of them. Now there's only 1, but that 1 would be a +4. Plus 2 N's, excuse me, and that's equal to this, that. So I got 1 HF, I got 3 HFs. So I need some more of this guy. There's my 3 HFs. I got 2 N's, I got 4 N's, so I need another one of this. And there's my final answer. So 1, 2, 3, 3 molecules of that, 1, 2 of that, and 1, leave it blank. And there's the final answer for that one. All right, next one. All right, PA, and then we have Roman numeral 5. So again, that means it's a +5, not that there are 5 of them. All right. So bring the 2 symbols across. We got PA and I. Don't bring the 2 across. That 2's there because iodine is diatomic. Now we do our charges. Well, it said PA was +5. Iodine is -1. Crisscross those. So we're going to 5 there, 1 there. Then we got to balance this. There's 1 PA, not 5 of them, plus 2 I's, and that's equal to a PA and 5 I's. Alright, so I got 1 PA, 1 PA. Then I got 2 I's, 5 I's. Oh, there's an even and an odd. So we go back, double this guy, start all over. Alright, so now I got 2 PA's, but I only got 1 PA. So I need to do this guy again. Alright, there's my 2 PA's. Then I've got 5, 10 I's. I got 2 I's. So there's 4, 6, 8, and there's 10. So now it's all even. So 1, 2, put a 2. 1, 2, 3, 4, 5. There's my 5. 1, 2, put a 2. And there's the final answer for that guy. Alright, on to the next one. Alright, last one in synthesis, Cu2 plus Cl2. Again, this one's got a Roman numeral again, tells us he's a +2. So we're going to bring over Cu and Cl. Don't bring the 2 because Cl is diatomic. Alright, now we do our charges. This guy's +2, this one's -1. Crisscross those. Put a 2 there, leave that one blank. Then we balance it. So I got 1 Cu plus 2 Cl's, and that's equal to a Cu and 2 Cl's. This one's already balanced just the way it sits, so we just leave it as a 1:1:1 ratio. Alright, that finishes synthesis. Now on to decomposition. Alright, first one, AgCl. That's going to break down. So in this one, what we do is we're going to tear them apart. So I'm going to take the 2 of them. Go Ag now plus Cl. I gotta look at each one and go, which one are they diatomic? Is Ag diatomic? Nope, he's not. Is Cl diatomic? Yep, he is. So I gotta put 2 on him. Alright, now I have to balance this. So I've got an Ag and a Cl. That's equal to an Ag plus 2 Cl's. Then I got 1 Ag, 1 Ag. Then I got one CL, two CLs. So I need some more of this guy. There's my two CLs. Now I messed up my AG, so I need another AG. And there we go, that's all even now. So I got 1, 2, 1, 2, and 1. And there's my final answer on that guy. All right, next one. AG20. So we bring them across and separate them. So we got AG plus O. Don't bring any numbers across. Now it goes AG diatomic. Nope, he wasn't last time. He's not this time. Is O diatomic? Yep. So we're going to put a 2 by him. Now we balance it. Whoops, I left my 2 out of here, didn't I? There we go. AG2O. Sorry. So we've got 2 AGs. I don't know. That's equal to an AG plus 2 O's. Alright, I got 1, 2 AGs, I got 1 AG. There's my, there, that's even now. Now I got 1 O, 2 O's. Oh, I need another one of this guy. I realized my 2 O's, but now I messed up my AGs. So I need some more AGs. There we go, now it's all even. So 1, 2, 2 of this guy, 4 of him, and 1 O, 2. And there's my final answer. Alright, next one. Alright, BaCl2. Alright, decompose it, tear it apart. So Ba plus Cl. Then it goes Ba diatomic. No, he's not. Is Cl diatomic? Yep. So we're going to put a 2 by him. Now I got to balance it. So I got a Ba and 2 Cls. That's equal to a Ba plus 2 Cls. That one's already balanced again. Isn't that ironic? But so we just leave it as a 1-to-1-to-1 ratio. So that one's done. Alright, now we go on to single replacement. It says all of these will react, so I don't have to worry about whether or not they're going to react or not. So we got Ga, and he's a Roman numeral 2, plus H2SO4. Alright, so I look at this guy that's all by himself and go, what charge would he have? Well, we got Roman numeral 2, so he'd be a positive 2. So that means he's going to kick off the positive piece of this. Well, remember, the positive piece is always the first one. There's my positive piece. This SO4, that's from the polyatomic ion page, and he's a -2. So these two guys are going to trade places. So we're going to get H all by itself. Don't bring a number across. Plus, we got Ga joins up with SO4. Oh, now I brought a number across. Why? From the polyatomic ion page, right? Now I go back. H, is he diatomic? Yes. So I'll put a 2 by him. Then we go Ga is plus 2, SO4 is -2. Oh, there's my formula for that guy. All right, now I have to balance it. So I go back and go, there's 1 Ga plus 2 H's and S and 4 O's, and that's equal to 2 H's plus a Ga, S, and 4 O's. So I got 1 Ga, 1 Ga, 1 S, 1 S, 2 H's, 2 H's, 4 O's, 4 O's. Oh, that one's balanced just the way it sits also. All right, that takes us on to the next one for single replacement. All right, next one we got Cl2 plus KBr. All right, so we look at this guy that's all by himself and go, what charge would he have? He'd be a negative. So if he's a negative, that means he's going to kick off the negative piece of KBr. Remember, positive is first, negative is second. So there's my negative guy. All right, this guy would be the positive. So the Br is going to get kicked off, and then the K is going to join up with Cl. Don't bring any numbers across. Nothing came from the polyatomic ion page. Now look at this guy. He goes, Br, is he diatomic? Yep. So I put a 2. K is +1, Cl is -1, so there's my formula for that guy. All right, now I got to balance it. So I got a Cl plus a K and a Br. That's equal to a Br and a Br plus a K and a Cl. All right, so I got 2 Cl's one CL. Oh, need another one of this guy. There we go, there's my two CLs now. I got a K, and I got 1, 2 Ks. Oh, need another one of this guy. There's my 2 Ks. Then BRs, I got 1, 2 BRs, 1, 2 BRs. Alright, there it is. So 1, leave it blank, 1, 2, put a 2, 1, leave it blank, 1, 2, put a 2. And there's my final answer. Alright, last one. And single replacement. How am I doing on my time? Okay. Alright, Li plus CMF3. Alright, Li, when he's all by himself, what charge would he have? He'd have a +1. So what's the positive piece here? Well, it's CM. CM would have a +3 and F would be a -1. So these two guys are going to trade places. So CM, curium actually, is going to get kicked off. And we're going to get Li joins up with F. Don't bring any numbers across because nothing came from the polyatomic ion page. Curium, diatomic? Nope. Alright, so this guy's +1, -1. There's my formula, LiF. Now I go through it and balance this. So I got Li plus, I got a CM, and 3 Fs. And that's equal to a CM plus an Li and an F. So I got 1 Li, 1 Li, 1 CM, 3 Fs, oh, I only got 1 F. So I need some more of this guy. There's my 3 Fs. I messed up my LIs. There we go. Now it's all even. So I got 1, 2, 3, put a 3, 1, leave it blank, 1, leave it blank, 1, 2, 3, put a 3. And there's my final answer. All right, we're going to stop on that one. We're going to move on to part number 3 because I'm running out of time for this one. See you in a bit.